Hey YouTube, XCT here. We are continuing the series on Shinra with a video on using the SSH key we found last time to get low privileged access to another machine on the network. Then we will escalate privileges by doing some beginner level reverse engineering, and we will exploit a custom time-based authenticator app followed by some post-exploitation work. So let's get started. Remember last time we got SSH keys. There's linda.pub and linda.key. And this shows us which user we need to connect as and where to. And you can see the domain is in here. So this is a login that's using domain credentials. So let's actually try that. Remember that you have to start like the SOCKS proxy on Web01 to get into the network. So I already did that here and have a SOCKS proxy running on port 9090. All right, let's try to connect there. This proxy chains SSH, and it's asking us for a passphrase. So there's something we have to crack again here. So what can we do to crack it? The usual way would be SSH to John. Then we give it the key and we create a hash file. We just call it linda.hash. And then we can run John on it. Just copy that so it gets a bit faster. Just like this. Oh yeah, let me remove my pod file here, because I already cracked it. Now we can try to run it again. And this takes quite some time. So even for the smaller ROCU 75 here, it's fairly slow. So you can do that if you have a GPU. That's totally a valid way to do it. Just use the full word list and you will crack it. But there's also another way. If you remember the first video, you notice we got a couple of credentials here, right? And one of them was for Linda Perry. And the key we got here is actually for Linda Perry. So we have a potential credential here, which is Linda 1987. So we might as well just try that, right? So let's do that. And here we go, it worked. We could connect to the box. So you can either crack it or basically reuse the credential we found earlier, right? So now we are fresh on this box. Let's see if there's anything interesting in the home. Well, there's one thing here, which is .ansible. This is interesting. So this might be an Ansible server, right? Other than that, we don't really know much yet. I guess if you do a lot of hack the box and stuff like that, you would just run a private script here, and that's fine to do. Just know that if you run something like linpiece, it will get detected and the SOC will actually get a couple of alerts. So maybe you want to be a bit more stealthy, write a custom program that does it, or like just use select commands instead of running a big script like linpiece. One thing we can do is we can look if we can execute something as sudo, right? But we don't really have the password of the user, so you can just enter the one we have from earlier, but it won't work. And also like wrong sudo entries could trigger some kind of detection. In this case, they don't, just know that they can. Another thing we can do is look for setuid binaries. I'm going to do that manually here. Find on the whole file system with setuid and then just throw the errors away, right? So let's have a look through this list and see if we can find anything interesting. All right, a lot of these are like default binaries, and if you've done it a few times, you will recognize them fairly quickly. So let's see if there's anything unusual. There's actually one that's placed here that's not like one of the defaults, which is user bin elevate. Kind of doesn't seem too unusual, but it is, and we will see in a second. This is owned by root and has setuid bits, so we might be able to use that to escalate our privileges. So first of all, let's try to find out what this binary is supposed to do, because it has to be there for a reason, right? No one would just put setuid bit on a random binary unless it's CTF when it's not needed. So let's just run it and see what it's actually doing, right? So it's asking for input. Let's just provide some here. And it's telling us wrong code. So apparently if we enter the right code, we might get some privileged action, maybe even a shell. just an assumption at this point, but it's called elevate, and maybe it's supposed to elevate your privileges, right? In order to find out what this is actually doing, let's copy it over to our machine. So let's copy this here. And then we want to see what this binary is doing. But before I check that one out, of course, you can do more enumeration on the box, right? You don't have to directly jump on this. You can also run the prevesc scripts if you want to. Or just, I think a good idea is always to like see if there's anything interesting in logs here, something unusual. Doesn't really look like this at the moment, but could be, right? Also, a good directory to check is always the opt directory. And here we can also see like two things that are not like on every box, which is elastic. So if we look at the processes, we see that the elastic agent is running here as well. So this box is protected by the EDR. And there was another folder. It was called playbooks. And if you ever come into contact with Ansible, you know that it has playbooks and you can basically use them to set up server machines. And we can also go to like etc, see if there's something unusual. And we indeed have Ansible here as well, right? So we could go here and there's a config. So let's have a short look at that one. There's nothing too unusual here, but maybe in one of the other files, like hosts. And here we have something that's not default. So we can see that this Ansible server is actually controlling two other machines, Registry and Prov. And Prov is basically the machine we are on right now. So this is the IP we just connected to. And Registry is another one. And you can see that both their SSH keys, well, Ansible needs the SSH keys to control the machines, right? Both the SSH keys are stored on this server in the root directory. So we can already see the path ahead a bit, right? If we can get root, we can use the key to connect to the next server. That's just some additional notes for the enumeration part here. So we got the binary. Let's do a strings on it quickly to like see if there's something easy to spot. Maybe the password is like in a clear text here, right? But that's not the case. So we can see a string a root secret. So maybe it's reading it from there instead of having it hard-coded. We can see that there's indeed a case where you enter the correct code and it's at least printing elevating, followed directly by bin bash. So maybe this is actually, if you enter the correct code, just executing bash for you and you get a root shell. That's also just an assumption at this point, but it could very well be the case. All right, so let's start analyzing the binary a bit. I loaded this here into Ghidra and went to the main function. And now we can just have a look through it and see if we can find anything interesting or vulnerable or something like that, right? So when the binary runs, it sets UID and GID to 0. So at this point, it runs effectively with root privileges. And what it's doing next is it's opening a file, root secret. We saw that in strings. And it's reading its contents into this variable here. So let's see where this variable is used again. It's then using some HMAC context. So it's doing some crypto. It's taking the string length of the contents of that file. And then it's doing HMAC init with the length and with the content of what was in that file. And this is being used to init some crypto stuff. I don't want to go into too much detail here because it's not important, but just know that this is some kind of seed to some crypto stuff that's going on. We can also see that it gets the actual time here. So this kind of makes us think it could be something like a TOTP, some time-based code that you have to enter. But in order for that to work, both sides have to have the secret, the same one that is in this file, and we can't get to that. So we can't just like code a client application without having the actual secret. So we have to do something else here. Let's see. It's doing some more operations here. We don't really know at this point what this is exactly doing, and it's also not too important. The result is stored in local 288. So let's scroll up a bit. Okay, there are several buffers here. We can see this local 288. This is where it actually stores the code that the server generated. And Then we have two surrounding buffers we don't know anything about yet. So let's see. It's then doing a scanf to 298. That's interesting. 298 is the buffer directly above it. Just to keep that in mind. It's reading our user input into that buffer, and then it's doing a string compare between our input and the code that the server generated. So if the code is correct, so if they match, it will just execute bash with these root privileges. So ideally we want both of these strings to match. So how can we do that? Well, for the scanf here, there isn't really any size restriction. So we could use that to overflow the buffer. And you might think, well, we could maybe override like the return address, I don't know, do a stack overflow, do rob or something like that. But it's actually easier than that, because if we go up again, remember this is the buffer with the code that the server generated. And this is the buffer our input is read into, and we can actually overflow that one, right? So nothing is really stopping us from writing our code here and then overflowing into the code that the server generated. And if they both match, well, then we just get to the root part here, right? All right, let's actually try that out. So first, if we want to dynamically debug this, we have to actually make it owned by root and give it the setUID bit as well. Don't do that if you don't know what the binary is doing. This is dangerous. So I'm just doing it here because I exactly know what it's doing, right? Let's change the owner, and then we also want to give it the setUID bit. All right, and now we should be able to run it. Yes. You also need this secret file inside the root directory. I already created that one. All right, now we are able to debug this. So let's do GDB. I use the Jeff variant because that's some nice additions. Use whatever you like. And now we can run it. And actually, let's find a good place to put a breakpoint here. Ideally, I want to have a breakpoint on the string compare, because that will allow us to see, basically, if we try to overwrite it, what's actually in memory. So that's on 473 here. So disassemble main, look for 473. Right, it's here, right? So main plus 570. So let's break them. And then the other thing we want to do is run it with an argument. And one way you can do this in GDB is by using this syntax. Just copy that here like this. And then we have to close it like this, exactly. And this will just be like the input it's expecting from standard in. So let's just put 1, 2, 3 here for now, run it. And now we are on the string compare, and we can see it's comparing 1, 2, 3 with a value that the server generated. And now we actually know how this value looks like. It's a couple of numbers, and it's comparing them to our input. And we don't really have a way of knowing which kind of number that is. And if we run it again, you can see that the number changes. So it's really a time-based authentication token. And without the secret, it will be hard for us to generate a valid one. So at this point, we want to try to overwrite it. So let's see how many characters this is. It's 9 different characters. So what do we want to do? We can try to do like A, B, C, D, E, F, G, H. So that's 9 as well. If I haven't counted wrong, no, like this, right? Yes, now it's 9. Then we could try to put a null byte, and then we could try to put the same thing again and a null byte again. Why the null byte? Well, it's a string compare, right? And we have to terminate the string. So let's see what this actually gives us. And this sort of worked. You can see that the normal code that the server generated is no longer here. We kind of messed with it. And it's showing our input here. And we have partially overridden, but we are not really at the point where we need to be. At this point, a really easy thing we can do is we can just try to pad this until it matches. So let's put like 4 values of padding here, and we're getting close, right? Looks like we're still missing 2. And now it really looks like we have the memory layout right. So we needed a few bytes of padding here. Both are null terminated. And this looks kind of good, I think. Let's continue here and see if this actually works. And yeah, it's telling us correct code elevating. So should definitely save that payload. Let's do that one more and actually look at the memory here. And yeah, you can see now it's perfectly overwritten. In contrast to our first attempt, just going to show that one again, just to make it clear. Here we have like a partial overwrite. Only like the 48 and 47 are bleeding into the value it's comparing with. But by adding the padding, we make it perfect. Okay, so we know how this works now. The only thing really left is how do we call the thing on the remote end. We can't run it in a debugger, right? Because we would lose the setUID bit. So we have to provide these null bytes somehow on the command line. One way to do that is we can do it like this. Let me explain that for a second. Basically, we're telling cut to read this from our command line, and then with the dash, we're telling it to stay open. So basically, let me just remove that. If I do it like this, it would print our input into the console, and then it would stay open. And this is important because otherwise we wouldn't get the root child, would just close. So we do it like this and then pipe this to user bin wait. And it's saying correct code and we are root. So this is how we exploit this binary. It's not a huge effort to actually do it, but I think it's a good intro to like play with binary, do some light reversing and all of that, right? So, okay, let's continue. We got root. Let's go to the root folder here. All right, so let's have a look here what we can find. First of all, let's actually get a PTY. So the shell looks a bit nicer. Then let's do an ls here again. And we can see there's a root.yaml file here. So that usually should be the flag on this lab, but it's not. So what do we have here? Well, that's an Ansible vault file. So what is the Ansible vault? Basically, it allows you to encrypt any data blob with a password with AES 256 here. So the good thing is there's actually an Ansible to John script that can convert this to a crackable format. So first of all, let's put this here. Let's do, just call this Ansible. And then we can do Ansible to John on this file. And we call it root.hash. All right, now it's in a crackable format. And now we can try to crack it with John. So let's just use it like we did before with the rockyou.txt word list. See if anything comes back. And here we go, we get a password. So this is the password to decrypt this YAML file. So how do we decrypt it? Well, first of all, let's make a copy here. Let's go here. Now we have a copy. And there's a binary called Ansible decrypt. It's called Ansible vault decrypt. And then you just give it the file. And it should ask us for a password. Yes. And we should be able to copy it here. Decryption successful, and you can see that the file size like substantially decreased, and now it's the clear text file. I don't want to show the flag here, so maybe we can do like this and then do a cut and maybe just go for the separator and select the first part. Yeah, you can see it's VL and then there would be like curly braces and a flag value. So we got the flag on this box. That's nice and all, but we also want to continue, right? So remember, we saw in the etc Ansible hosts file that This Ansible server controls another machine called the registry, and its SSH key should be in .ssh in root. So let's go there. And indeed, we have the key here for registry. So that's nice. The question is, can we actually use it? And we can try it just like this. -I for the private key. And in the config, it should have told us where to. Yeah, that's this IP. So let's copy this. You can see it worked. Don't mind these color code thingies here. I think this is just some issue with the console. So why do we know it's root? Well, Ansible is a system that is supposed to like control, install other servers. So usually it would be a privileged user. Doesn't necessarily have to be root, but there's a good chance it is actually root. So now we actually made it to the registry system. So we can confirm that here. And yeah, we are on the next box. So that's it for this video. I hope you enjoyed it. Next time we will explore the machine we just got access to and get further into the network. Thank you all for watching. I really appreciate it, and see you next time.